3.5, number 180. So the goal is to use the previously mentioned derivatives of trigonometric functions in tandem with all the other rules that we have learned so far. So in this particular problem, we have y equals sine x tan x, and we're supposed to find, using Leibniz notation, dy dx. Since the question has begun with this particular notation, I will continue to use it throughout the rest of the problem. So we need to find dy dx. So dy dx is, of course, just the derivative operator d dx, right? The derivative with respect to x applied to y, and y is sine x tan x. Since the most outer operation happening with this function is this product, we must first use the product rule before we use any type of derivative of trigonometric functions. We need to go ahead and apply the product rule first. So we will have the first function, sine x, times the derivative of the second. Again, I'm just replacing my usual prime or tick mark derivative operation with this d dx. The tick mark comes after the function, d dx comes before the function it's applicable to. All right? So first times derivative second, derivative not yet taken, plus second times derivative of the first. Okay, so now we have two small derivatives to take, but we do have our product rule laid out in its usual formulaic way. All right, so continuing on, sine x stays unchanged, sine x. And now the derivative of tan x is the memorized fact secant squared. So there's a product there, sine x times secant squared x, plus tan x unchanged, times the derivative of sine, which is, of course, the memorized fact of cosine. So there is our derivative fully taken. The only thing you want to do is attempt to clean it up however you can using the usual rules for trigonometric identities. So, for example, tan x is, of course, sine on cos. So this is kind of crying out here on the far right for a manipulation. So you have sine x secant squared x. And what I'm about to do may not seem so useful or necessary here, but it will be extremely necessary in later problems where there's more to do besides just finding the derivative. So you'll see what I mean in one moment. So sine x secant squared x plus tan x is sine x on cos x, and we have times another cos x. So of course the cos's cancel. There's that simplification. Equals, we now have sine x secant squared plus just a sine. So what was the advantage of all that? Well, it is simpler looking, but besides that, what we've been able to do now is actually turn this into a product. It's right now a sum, right? Two-term sum. But now, if I factor off the sine x, I'll have secant squared x plus 1 as the second factor. So I turned a sum into a product expression. And again, that may not seem that useful, but it is extremely useful when you have to set these things equal to 0, which is a common theme throughout the course, even though not applied to this particular problem. So changing sums into products whenever you can, factoring wherever you can, is extremely useful, and you should try to get used to it before the more serious problems hit.